Thank you, everyone, for joining the Uplink today. I'm Jacob Swen, marketing manager with Nova Labs, founding team behind the Helium Network, and super excited to have Manos from WeatherXM here with me today to talk about everything that WeatherXM is doing. I did a short little interview with Manos a couple weeks ago for like a new user announcement. And wrote a little blog about, just a high level overview of what they're doing, but he's going to dive into a little more detail about WeatherXM's use cases. They're really cool weather stations. I know even a couple of my coworkers have these weather stations up on their roofs right now. So everyone's excited about it. And a little bit about like the reward system and things that WeatherXM has got mapped out. But first, I'm going to dive into a little overview of Helium, just in case people aren't aware. So Helium's a people-powered network built by the community for the community. Where everything's community-driven from any changes, anything like that. So really cool to have just everyone kind of pitching in and building this awesome network. So Helium was founded in 2013 with a mission to make it easier to build decentralized wireless networks. And we've done that with the largest decentralized wireless network in the world. Awesome to say that. But to be able to get here, we've had a lot of help and been backed by some of the best VC firms in the world. This is not all of them on this logo wall, but this is some of the first ones to invest. So you can see that. Margaret, be careful you don't mute me. Okay. Super excited to be able to say thanks to these people for helping us get to where we're at right now. Some stats, always out of date as soon as I enter them because we're growing so quickly, but I tried to get these as up to date as possible. We're at 890,000 plus hotspots, closing in on that 900,000, then a million, which will be really cool. I always like to say, when I first started a little over a year ago, I wrote a blog and we were at I think like 14,000 hotspots online. So to grow from that to almost a million in just a year is amazing, in over 67,000 cities and 180 countries around the world. A couple of the kind of the selling points for the network. These are not all of them, obviously, but some things we, like to brag about a little bit. Low data transfer costs for a device that sends data every 5 minutes. It costs around $1 per year. So that's very cheap to send data over the network. It's accessible and easy to use with pretty much any compatible off-the-shelf LoRaWAN device. So it's easy to get started and get up and running on the network through our console. There's increasing access to open source projects to avoid any issues such as vendor lock-in, things like that, because everything's open source, decentralized. You're not having to use any proprietary technology. And you pay based on usage. So you're not signing a contract. You're not being locked into anything that, might charge you for overages or things you don't use or anything like that. You pay when you send data over the network. WeatherXM is here as a new member of our ecosystem, and our ecosystem is growing. I think we had 60 new people join the ecosystem last month, I believe. And, we're halfway through July, and I think we're almost, 20, 30 more this month. Awesome use cases, stuff that I didn't even realize was possible. And it's all enabled by the network. So things like, connected weather stations, all types of asset tracking. We had smart connected beer kegs announced not long ago, pet trackers, all types of things. So check it out on our ecosystem page, just helium.com/ecosystem, and see all the different use cases that are coming onto the network and that are possible because of Helium. It's really cool to see people like WeatherXM and what they're doing with the network. Just some recent news. We did have our first community event in real life since before I worked here, but I think like 3 years, people have said Helium House ATX, where the community got together, got to, come up and speak about use cases. We had our team give some announcements. Our CEO got up and talked, did some presentations and things like that. In Austin, we are going to have, and that's on my next slide, I think, but another one of these in September in New York City. So stay tuned for more details. You can also watch, if you missed any of the Helium House ATX stuff, you can watch the stream on our YouTube channel as well and kind of catch up on that. This is like our big thing this summer. Very exciting. We've got Helium 5G is here, ready to go. So this is our cellular summer, we're calling it. make sure to go check it out on helium.com/summer and, see how you can get involved in building out the 5G network. Now we built out the IoT network, like I showed, almost 1 million hotspots there, but Now we're building the 5G network. Super exciting to get in right at the beginning here. So make sure to stay tuned for updates on that. And like I said, we hit 850,000 hotspots, almost at 900,000 now. I've announced a couple new users, including WeatherXM, Skipley, and SenseGreen. Just announced them recently, have uplinks with them. I think SenseGreen next week, Skipley the week after. So stay tuned for announcements with that as well. Whoops. I guess I don't have another slide there. So Manos, I'm going to hand it over to you. You can intro yourself, talk a little bit about, just give us an overview of WeatherXM, and then you can dive into kind of a little more detail, and we'll do some Q&A at the end for everybody.
Sure, thanks. So yeah, in a nutshell, WeatherXM is a community-owned weather station network that rewards the weather station owners for the data that they share with the platform, and builds services, weather services on this data, sells those weather services to enterprises that are weather sensitive, and rewards back the original weather station owners that gave the data in the first place. But I want to go back to how it all started. So I have a couple of slides here that they kind of show the background, but also the future, if you like. So we, as a team and as a company, we exist for a couple of years now. We have been working in the industrial IoT space with large customers from the energy sector, like energy utilities. We were doing energy demand forecast for them and advanced weather analytics. We worked with telecommunication providers, with airports, with marine ports, and those sort of companies, basically. And now with all these customers are weather sensitive, and what they require basically is very accurate forecasts, but they also require knowledge of weather conditions, historical, present, and future-wise. So from the beginning, we had a lot of trouble finding weather data, and that's kind of normal because weather data usually come from sensors, from weather stations. Weather stations are difficult to deploy, expensive. They require energy. Usually, they have to be connected to mains power. So it's normal and expected that the global, let's say, situation with weather stations is not ideal, especially if you go to countries other than the US, that their meteorological departments, the governmental meteorological departments, don't have the resources to build very dense weather station networks. So we started working on this problem for the last couple of years. And we initially approached it from the hardware point of view. So we thought if we can make a better weather station hardware-wise, then this would be enough to expand, let's say, a global network of weather stations, or at least use this hardware for our own benefit, like for our own customers. So a couple of years ago, 2018, we went to Shenzhen, China, and we started building our own hardware. And a number of things has happened since then, but essentially today I guess we are in the position to claim that we have created the world's first Web3 weather stations, basically. And what does this mean? It means that we have a traditional weather station that is monitoring, the typical environmental atmospheric conditions like precipitation, wind, temperature, humidity, pressure, and solar radiation. But this data goes as directly as possible to Web3 technologies. So it goes to IPFS and Filecoin. There's a number of proofs involved in the process. So we know this data is coming from our own hardware. So we have proof of device. We also have a number of proofs regarding the location. So we know where our devices are. we're using encrypted GPS communication, as well as a number of additional mechanisms to confirm the location of our device. And actually, Helium is one of those mechanisms, because signals received from Helium gateways also provide some proof of location. So we have created this hardware, and there's a number of things that we can do with this hardware in the Web3 space. We have let's say our vision is split in 3 phases. Right now we're in phase 1. So those phases are quite, substantial and quite different. One could claim that they are almost like 3 different companies. So in the phase that we're currently at, we're just building the network. So we're focused on the supply side. We're delivering weather stations. Those weather stations are directly connected with our Web3 infrastructure. So when people deploy the weather stations and they share the weather data with us, we confirm the quality of the data, and we reward them back with our own token. Our token has been launched yet on a mainnet, but this mechanism has been operational for a couple of months now in testnets, in Polygon testnet actually. So this is phase 1, and we're obviously using the crypto incentive mechanism as means to build a global network, and it's going quite well. And our community has grown in a couple of months to 8,000 people, and basically half of them have already purchased our weather stations, and we have shipped around 1,000 weather stations, which are being deployed on a daily basis. So these people, at this point, they get a mobile app, and we recently launched our web app as well, which is basically the same as the Android mobile app, but for web devices or iOS, as we're waiting for Apple to approve our app, the iOS app. Anyway, so what people get is an accurate forecast that is being built on the historical weather data that the stations collect, obviously the historical data that they produce, and the token rewards that are related with their contribution in the system. So they can put their MetaMask wallet account and receive the daily rewards. Now, this is just the supply side. So this is phase 1, but phase 1 right now does not really have any customers. And the customers we have in mind are large enterprises that need accurate weather forecasts. So the kind of customers that we had all these years as a traditional Web2 company. And there are a number of different sectors that require very accurate forecasts, but I think one of the most interesting ones is agriculture for us. So I'm using it here as an example. I think it will make more sense with the future plans that we have. So the use case, therefore, we are aiming at, or at least one of the use cases we're aiming at, is to provide agri-tech companies with more accurate weather forecast, historical weather data, and the ability to enhance their solution, their vertical precision agriculture solutions, with a weather station that is low in cost, easy to deploy, energy autonomous, and in some cases, its cost could be subsidized by crypto enthusiasts who want to participate in this mix and get some of the crypto rewards in exchange. So this is what we call phase 2. This is where we see revenue coming from selling services. And we have a transparent mechanism. We're building a transparent mechanism where the revenue from those services goes directly into the token through a burn and mint mechanism. And therefore, the value that is produced from the weather station owners, it goes back basically to their token. Now, these are great. I think those 2 phases are enough to build a very interesting global network. But long term, what we have in mind relates with weather oracles and the insurance industry. So, I mean, the weather industry, for example, in the agriculture space is a few hundred million in terms of market size. And the global insurance industry, from a crop perspective, is a couple of billions. And even though it's a very large industry, even though it's a traditional and old industry that has tried a number of different approaches to modernize and to do the digital transformation, as we say, we still think that they have a lot of things to do. And one of the reasons is because in developing countries, for example, in Africa, people essentially, farmers don't have access to their services. So there's a lot of space for improvement, let's say. And we believe this improvement will come from the blockchain angle. So we think that it makes sense for insurance companies, brokers, to try to modernize their services by taking advantage of smart contracts in blockchain. And when they do that, they will also require weather data on chain. And this more or less doesn't exist today. I mean, there are mechanisms that you can bring weather data on chain through Oracle technologies, but usually today the situation is that you have to copy paste weather data from legacy systems onto blockchain networks and use them in smart contracts. And we think that's wrong. We think there should be a native Web3 infrastructure for weather data that is built from ground up, including the hardware, including specialized hardware to do this. So long-term, phase 3, as we call it, we see all these things combined. So we see a massive, hopefully, weather station network that is utilized in a number of different industries, such as agriculture, but it can also power a blockchain weather crop insurance of the future, as well as any other kind of smart contract that requires weather data on chain. So we hope that this is going to become something like Helium for weather. And I will quickly walk you through our website, actually. Yeah. So if one goes to our website right now, we have a number of different hardware options. Right now the focus is in the first 2 versions, let's say. We have worked so far in 4 different versions, but the only 2 are available for sale. Well, actually, they're not even available at this moment, but people can register in our waiting list. And in the next couple of days, we will actually initiate sales for the Helium weather station version. And in parallel, we have a lot of pre-orders for the Wi-Fi version that we are now basically delivering. So,
Manos, do you have any of those in person that you can?
Yep.
Look at that.
Yeah.
Perfect.
So this is the first version that I was talking about. This is the weather sensors. This is what one has to deploy outside in his yard, let's say, or at the roof of his building. That's usually where people deploy those stations. And this station transmits every couple of seconds the weather information to a device that we used to call weather data miner. It's essentially a gateway that has some special crypto chip that allows us to sign the payload of this data and forward it to IPFS and to our infrastructure. We produced the first microcontroller client for IPFS, by the way, as an open source library. So we're trying to build as many things as we can open source, but the truth is that a lot of the things that we are currently working on, we haven't had a chance to open source them yet, but the plan is to have everything open, basically. Anyway, going back to the hardware, so weather data are coming from the weather station to this device. This device connects to your home Wi-Fi and forwards this data into our infrastructure and decentralized file systems in general. And this is cool, this is great. We have a small screen, but it has a number of limitations. So it needs power. It's USB powered, but still it needs power. And it also needs a Wi-Fi. So the second version of the hardware that we've built is the Helium version. And so this one is more autonomous than the previous one in the sense that it doesn't require our gateway. It does use the Helium gateways, which are all over the world already. So there shouldn't be any additional requirements there. So as long as there is Helium coverage, that weather station will connect to the Helium network using LoRaWAN technology, forward data from the network layer to our infrastructure. Again, the data are signed with a special crypto chip that is built in this specific hardware. We are also using encrypted GPS communications to validate the location, to confirm the location of the station. We use the proof from Helium itself. So we have a number of different ways to confirm that the station is indeed there. And once we receive the weather data, we have what we call quality of data mechanism to confirm again that all the data are sane. We run a number of anomaly detection machine learning anomaly detection mechanisms that would, in the future at least, because everything now is under construction, but in the future we'll be able to filter out stations that someone might have deployed inside their house, for example, or at their balcony. Therefore, they're not receiving enough wind. They're not receiving the real conditions that are out there. They're just, receiving distorted, basically, conditions. So our goal is to be able to detect this and reduce the rewards or completely remove the rewards for those stations, because those data are not very useful to the network. So yeah, that's in terms of the hardware. And if one goes to our website, he can click on the Explorer, where we see all the stations that are currently deployed live. So right now we have 575 stations online. This number is slowly growing every day as people deploy more and more stations. And so in here we can see some basic weather information and some basic reward statistics for every station that is online. Obviously, all this is very early. We're developing a number of things at the same time. So this is like, we call this beta, but it's probably alpha. So there's a lot of things missing here, we know, and we're trying to develop everything and put it in as soon as we can. So yeah, this is the Explorer, and we have an awesome, amazing community in Discord of more than 8,000 people that we talk all the time, and we get very valuable feedback from them. This has helped us a lot, solving problems, debugging our mobile app, our hardware, and I think something very interesting that I really enjoy every time I visit this channel is all the deployments that we have worldwide. And you can see such a variety of buildings and locations and ways that people have figured out how to deploy the stations. and they're doing an amazing job. Often you see helium antennas next to the station, so it's cool. So yeah, that's more or less what I wanted to show you. It's a little bit of everything. I don't know how much time we have left for questions.
That's all right. Yeah, no, this is great. And I do see a lot of questions in the chat, and people have been having pretty good conversations. So we'll get to those. Is Discord the best way for people to get in touch with you, Manos, or kind of get questions answered, anything like that? Or is there a specific email or something you'd rather them go to?
Yeah, I think Discord is better. So if one goes to our website, weatherxm.com, we have links in our social media, and one of them is Discord.
Gotcha. All right. I see even a few people in here proud to be beta testers. So you've got some of the community in there. Awesome. Yeah, I'm going to scroll back and get to, like I said, we had a number of questions. Some have kind of been answered by people, but I'm still going to let you kind of have a chance to answer them as well, Manos. Let me see. Travis, actually from my team, asks, is that an M5 LoRa and GPS radio on the stack? Is that something you can answer?
Yeah. So M5, so the hardware that we use here is called M5 stack. So this is a hardware that existed already. It's from a company that's called M5 stack. And what we did is we modified one of the stacks, and we added some components that we needed and made this special version. So this device already has, this is based on an Espressif ESP32, which is a popular microcontroller for DIY enthusiasts. And it has a LoRa module, a GPS, and a couple of other things. It could act as a LoRaWAN device if we program it to do this, and it could connect in the Helium network, but we chose, for the first version of the devices, we chose to use it as a device that is listening to RF signals from the weather station, and is forwarding the data over Wi-Fi. The initial plan here was to use this as a development device. So we could, we are hoping that we will be able to release the firmware for this. This is based on FreeRTOS. So it's kind of, we started with some easy, we were hoping that, people could work on this, but it's becoming more and more complex. So I'm not sure, what people can do with this in the future, but hopefully once we release the source, I think a number of new opportunities will arise. For example, integrating with smart home solutions, exposing APIs and consuming data directly from the hardware instead of having to go through the cloud or through IPFS. Playing with the UI. This is our new UI. We haven't sent this to the users yet, but it's a major improvement in comparison to the UI that most people have today, which unfortunately is the development UI, because we don't have to, we shipped a lot of things, as fast as we could. Yeah, I think I covered this question. That's enough.
Yeah, all right. No, that's great. And like I said, if people want to follow up or anything, they can join your Discord and talk more about that. Nate wanted to know kind of what are some of the biggest upcoming challenges that you see as you build out the network and, deploy more weather stations and things like that? I know that's a broad question, so you can narrow it down to one or two.
So I can tell you the challenges we have so far. So we started, we put a small order in a factory like a year ago of 100 weather stations, and we were slowly selling weather stations while we were in stealth mode, let's say. And then overnight, all the stock was gone, and then we kind of accidentally sold like 200 weather stations. So we quickly changed this order to the factory. We went for 200 units, and then we tried to, organize our manufacturing process so we can meet higher demand. And we reached the point where we had 4,000 sales, and we couldn't find 4,000 GPS modules so we can manufacture 4,000 units. So we were kind of stuck in 1,000 devices for a period of time. And it was only recently that we managed to secure a large batch of GPS modules so we can continue the manufacturing process. So, this thing that people hear often, that there's problems in the supply chain and there's component shortages and so on. I mean, in some cases it could be an excuse, but most of the times I think is a real problem, and it could be a dead end, because you have to redesign hardware. We have to do some hardware modifications to overcome some of those problems, and from the beginning we tried to use as much as we could components that we thought that we wouldn't have any supply issues in the future. Obviously, there was one that didn't meet the criteria.
Yeah.
So yeah, I think those are the challenges of the future: meeting demand, which so far it's been, it's going great.
Yeah. And I think you're not the only ones with that challenge either. It's a worldwide challenge, but yeah, I understand that. Nico has kind of a long question here, so I'm going to paraphrase a little bit, but just talking about like with the insurance contracts that you mentioned, Manos, he's saying that weather data, I mean, these contracts usually need data sets with like long periods of weather data, long periods of time. So what's kind of the value proposition and major revenue driver for the data that you're generating if it's fairly new data? Does that make sense for those insurance contracts?
Yeah, so that's a good point. So insurance companies, they need a couple of things. One of them is they need a long history of weather data for a specific area, so they can assess the risk of extreme weather conditions in the future. So yeah, we cannot modify time. We cannot go back in time, but if we deploy weather stations in areas that didn't have any weather stations at all in the past, even that short window of time that we're going to have data is better than nothing. In addition to this, the phases that I described previously, in my mind, they're like a year or so. So if we're building the network now and we're delivering weather oracle services in 2 or 3 years, well, we will have enough historical data, to do more things than what is capable, what is happening today, basically.
Yeah. I'm going to jump in with just a kind of a basic question, but I'm curious, like, what made you guys choose Helium? Like, why did you start working with Helium? How did you, decide it was kind of the right choice for what you're trying to do?
So Helium has a number of benefits for us, a number of advantages. So it's a very low cost infrastructure network. And one of our early goals was to reduce the cost of this, of the infrastructure, that in general, the cost of the operation cost and the CapEx and the OpEx, as much as we could. So usually a global cellular network is going to be quite more expensive than Helium. That's one aspect. The second aspect is that we use a number of Web3 technologies, and Helium is pretty much compatible with what we're doing. So, for example, the proof of location, the blockchain stuff. I mean, there's a lot more things we can utilize in the Helium network that we could utilize in a traditional old school telecommunication provider that, at best case will have an API with some very basic stuff. But I think another important aspect is the fact that the Helium community is pretty much compatible with the WeatherXM community. I mean, I know some people are part of both, but in general, we have similar values. We believe that things should be as decentralized as possible. We are trying our best to work our way towards this direction. Obviously, today, a number of things that we do in WeatherXM is still controlled by the companies, is obviously centralized, but the intention here is to make it as transparent and as decentralized as possible, and eventually convert into a DAO. And so we have a lot of things in common, I believe, with Helium. And we also, get a lot of inspiration and lessons learned from how Helium has evolved over time.
Yeah, no, that's great. Stephen had a question kind of about which hemisphere the station's installed. He's wondering, like, will there be an option to switch between north and south, like with the solar panel, just for maximum electrical generation, like depending on which hemisphere the station is deployed on? I see your face. Yeah.
Yeah, actually, that's a very advanced question, but yeah, in our manual, I hope in our instructions we are saying that if you are at the south hemisphere, you have to deploy it in a different way than what we do in the north, and we should have some settings to correct for this. I need to check, but we definitely had it at some point in the development. I'm sure that the production version also has it. If we don't have it, we're gonna definitely have it in a future release. We have a very
Yeah.
powerful over-the-air firmware upgrade mechanism for the Wi-Fi devices, and for the Helium devices, we're also using Bluetooth, so users are able to connect with their smartphone directly to the station and correct or enhance those kind of things, like the issue that was mentioned before.
Yeah, no, that's great. Here's a question about just kind of changing the location. Like someone has a Wi-Fi version, but maybe they want to get the Helium one and move the Wi-Fi version to like a family member's house or something like that. Are they able to change the location, kind of
Yeah,
reassert where they're
yeah.
at? Yeah.
So yeah, right now we're not charging anything. I mean, there is no mechanism to control the relocation of the station, but the concept that we are planning to follow is similar to the Helium stations, basically. So there is a location fee that is already included in the price of the hardware. But if you deploy it at one place and then you decide in the future you want to move it somewhere else, this is not ideal for us, because we prefer to have as long as possible historical data for the same location. So we want to give an incentive to users to keep the stations at the same spot. If they decide to move, there is a small fee that they have to pay, which is usually covered by the rewards they have already taken. So it's not really a big issue, but it's just a part of the reward mechanism.
Gotcha. And piggybacking on that, I mean, I don't know how deep into the rewards talk you want to go right now. I have a couple rewards questions on here. Is it okay to ask them here? Or do you want to wait, on Discord or something like that? Okay. Andre here says it seems like all the online stations get the same rewards as long as the reward scale is 1. And will this be the same when mainnet is live, or will there be more systems to increase or lower rewards? Like how will the system reward stations in more rural areas?
Yeah, so right now the rewards are very basic. We have a way more complicated schema in mind than what is actually being executed in the production. So they are essentially three criteria that will define how the rewards, the actual rewards that every station will get. So the first criteria relates to the how good the deployment of the station is, and the quality of the weather data. And the second criteria relates with the location of the device in general, location in the world. And then we have some more flexible reward bonus kind of mechanisms, boosters, we call it reward booster, that has to do with specific business KPIs that will be relevant at the time. You could also see this as a bounty mechanism, so we can do more controlled rollouts in specific geographic areas. Now, right now, the two weather stations we use have the same accuracy on the sensors. However, we're working on some industrial versions that are better suited for extreme conditions. So we will introduce different classes of hardware in the future as well. That will also affect the rewards. So overall, the reward mechanism is going to be way more complicated than what people see in the last couple of months, that they have been receiving rewards that more or less, most of them get maximum rewards because their stations are in operation and they are sending data on a daily basis. So they meet the very basic criteria that we have set for the time being.
Awesome. All right, I'm going to take two more questions here out of chat just for time's sake. So if I didn't get to your question, make sure to follow up with Manos either on Discord, probably the best place on Discord, or by email. So Nick has, it's kind of a double question here. First one, will the updated station still require a bubble level on top? Will there be a way to orient and level from beneath the unit so we don't have to get on a ladder or check it? And is there like an auto level orientation option that you're looking into?
Yeah, well, that's kind of tricky if you take into account the cost reduction that we're trying to achieve here. So yeah, the stations we use today, to explain to other people what we're talking about. So there's a bubble here that you need to center when you deploy the sensors, because if you don't deploy it in a horizontal manner, then the wind sensors, the UV, and the rain sensor as well will not get 100% accurate readings. Could we avoid this in the future? With this hardware, no. So with the cost-efficient hardware, we need to have a bubble, and we need to make sure that the pole is vertical and the station is deployed horizontally. We have worked in the past on stations, the ones behind me actually, it's this one's over here. So we tried to do some tricky stuff with automatic orientation, with digital compass, building the hardware and things like that. The problem with those is that they drift over time. So we are increasing the cost of the hardware without increasing the accuracy, most likely. So I think it's better if we keep the bubble for now.
All right. All right. All right. Last one. And again, I know I'm skipping over a few here, but for time's sake, this one a little bit long, so I'm going to read it here. I have customers that are very interested in weather data in an offshore environment. So on the website, it says you're looking for applications in agriculture and maritime environments. Can the weather stations handle the harsh conditions of being like out in the ocean somewhere, out in open sea? And what would be the life expectancy and also maintenance, just because those locations don't get visited very often? You know, there may not be people out there for a long period of time.
Yeah, that's a good question. So these are low-cost weather stations. So they are not designed to be used in those kind of environments. Based on our experience, they will survive a couple of years. So it's not really an issue, but we wouldn't claim that those devices are designed for that. We have worked in the past in those kind of use cases. We have actually built one of the projects that we've done here in Greece. We have created the national water quality network. So we have deployed equipment to about 30 rivers nationwide, and we're looking at a number of different parameters in real time. And one of them is water quality, by the way. So yeah, we understand the challenges there. This is something that we would like to look into the future. We have attempted to design at some point some sea buoys, weather stations that could be deployed in the sea, basically. But I don't think this is going to be a high priority at this point, unless we have a very important customer that is kind of forcing us to explore this in parallel to the other stuff. I think right now our focus is on these mainstream traditional basic weather stations, let's say, and we're going to leave exotic use cases for the future once we have most of the infrastructure in a good state.
All right. I'm going to put up my screen one more time, Manos, just for some contact info here while I kind of say thank you for being here. If anyone wants to, if you're not already in touch with us over at Helium, make sure to follow us on GitHub, Twitter. Our Discord has, I don't know, hundreds of thousands of people on there, tons of good resources. You can shoot me an email at jacob@nova.xyz or Mark Phillips, who's our head of BD at mark@nova.xyz. If you have any questions about getting going with Helium or anything, but I just want to say thank you to Manos for being here. I mean, that was one of the better chats and Q&A sessions that we've had for a long time. So that means you're doing something right and you got people interested. So that's awesome. And again, if anyone wants to get in touch with Manos, Discord's the best way. Go to the website. You can join from there. And we're excited to see everything that WeatherXM is doing for the future, and excited to have you as part of the ecosystem, Manos. So thank you.
Thank you as well. Thank you, guys.
All right. All right. We'll see everyone next time for another episode of the Uplink. Thank you all.